Thank you, Radhika, and very warm welcome to our very big and growing Indo-German family. It gives me immense pleasure to be presenting to all of you. I am taking almost 112 man hours of your time of your life, and this is priceless. It has no value. So thank you really for that. And I hope whatever I can share today, you gain some insights. I've tried to distill everything that I've learned in the last 44 years and a very strong foundation, which was laid for me as a human being at IGTC from 1998 to 2000. So let me start sharing my screen and my presentation, and then I will tell you the story, which hopefully you will enjoy. Is my screen visible, I hope? And let me try to hide this. Okay. So before we begin the presentation, I just want to give you a quick view about my life. I started working when I was 16 years old. I went out and found myself the one possible job a 16-year-old can get at that time in India, which was 1995, and that was to go and do sales promotions in a supermarket. And that's where I really observed consumer behavior, brand strategy execution, and all the 4 Ps or 7 Ps of marketing, which later on I discovered when I joined IGTC as a management trainee, being sponsored fully by Michael Bosch, for which I'm ever so grateful. So I've had a very interesting career journey and a personal life journey. I've also met my life partner in IGTC. So IGTC really was the turning point of my life in more ways than one. And therefore, I'm deeply connected to IGTC, and it's like a umbilical cord which will never break. So today's presentation is, it's called An Electric Horse Meets a Diesel Dinosaur. And it's ironic that I don't know if you read recently, the CEO of Volkswagen in the US is facing charges for what is called as the Diesel Gate. And Volkswagen, the founder of Volkswagen, Herr Ferdinand Porsche, was in fact the father of the first electric vehicle ever produced. And 135 years later, we now have all cars which are running on diesel and petrol, and electric has now come back again to challenge the incumbents. And this story is about how the entire smart mobility ecosystem is coming about, and I hope you can draw some parallels in other industry verticals of digitization that is ongoing. And in fact, we are all part of that entire journey. So as I shared with you, I was in IGTC batch 98-2000. And post that, I was continued working in Bosch until 2004. And then I moved to Dubai, worked with Black & Decker and Sony for 8 years in the Middle East and Africa region. I came back to India in 2012 and led the business development for Blaupunkt in India. And in 2015, I joined HCL Technologies. And that was a good break because based out of India, I had a global role as head of connected car and artificial intelligence practice in the engineering and R&D services business of HCL, which was in all a $2.5 billion business, and overall HCL today is $10 billion. And then I joined ZF Wapco in 1st of October 2019. And most recently, I've moved out of traditional corporate job, and now I've joined Bridge for Billions as a global mentor for startups. And I also do consulting work, and I'm trying to explore other ways of creating, capturing, and delivering value with everything that I've gained over the last 22 years. In 2014 and 15, I had the privilege of doing a one-year program with MIT, and I can tell you that having gained the foundation at Indo-German, which is the Duale Hochschule, or the dual system of education and training, I had a great advantage in MIT, because MIT was manus et menus, which basically means mind and hand. And mind and hand was already implemented by Indo-German way back in '91. So I had a great advantage of that foundation, and reinforced my learnings and insights when I went to Sloan, Cambridge, USA. Apart from that, I've been constantly learning and writing articles on technology, trying to demystify complex technology to connect with the common man, so to speak. And I speak at industry events. I'm on various panels as far as automotive connected car is concerned. And most recently, I've started a YouTube channel, and I speak on smart mobility solutions and leadership development. I've also had the privilege of traveling extensively for business and leisure. Traveled over 38 countries and 100 cities over the last 22 years. And I consider myself to be a global citizen. And I hope that we can create a world without borders and truly become global citizens, which is, I think, the need of the hour. And the pandemic has only made all of us realize that everybody is connected, that everybody is happy if everybody is safe. So these are some of the articles. And the first article, when an electric car meets a diesel dinosaur, is the basis of today's presentation. And I've also written one called The Next Mobile is the Automobile, and you will see insights from that article as well in this presentation. So let's begin. So the story of automotive, like I said, is about 130, 135 years old. And in 1899, at the Berlin International Motor Show, the winner of the motor show was an electric vehicle, which you can see here on the right-hand side from the Stuttgart Museum. An electric vehicle made by Ferdinand Porsche. He was a great inventor, perhaps far ahead of his times. And not only did he invent the electric vehicle, which successfully ran a few miles and won the first place as against gasoline and diesel vehicles, but he also invented a fantastic concept called the octagonal motor, wherein you have the motor assembled along with the wheel. And this concept is what is now used for all the space exploration vehicles. So he was really far ahead of his times. And unfortunately, the electric vehicles of Herr Porsche did not take off at that time. The gasoline and diesel vehicles took off very well. And then, of course, the world went behind fossil fuels, and the rest is history. But if there was a parallel universe, the electric vehicle would have been the main runner, and we wouldn't perhaps have all of the pollution that we have in transportation, owing to transportation worldwide, and we would have had a much more greener world. But it's never late. The electric vehicle revolution is coming back, and let's hope that this time we make it and we make the world safer and greener. But how are we going to create this revolution, and how are we going to digitize and digitalize the entire ecosystem of smart mobility? Let's try to understand. So first off, how does the automotive industry put together a fantastic automobile that anyone with or without license can drive and still be safe in the car? So here is an acronym which is very popular in the automotive industry circles. And this acronym is called as BICEPS, B-I-C-E-P-S. Now this acronym indicates all the subsystems that's required to put together a car. So B stands for body, I stands for interior, C stands for chassis, E for electronics, electricals, and P for powertrain, and S has been added over the last 15 years, and S is for software. So for about, out of this 135 years, for about 110 to 20 years, the car, as you know, was just a mechatronic assembly line. That's all it was. It was a huge, clunky 5,000, 7,000 components assembled into various subsystems. The tier 2 component suppliers would supply to tier 1 companies like Bosch, Continental, Delphi, for example. And then the tier 1 companies would then supply the subsystems such as engine and body controls, powertrain to the OEM like Daimler, Volkswagen, and BMW, for example. And the OEM, original equipment manufacturer, would assemble these subsystems in the factory, as you can see in the picture, and then market the product under their brand name, and then control the B2B channel, the B2C channel of brand building and delivering the product, and managing the entire aftermarket network for service requirements. This was the story for about 120 years. But then, in 2007, the world changed. So, in 2007, when iPhone was launched, this is the first time a full touch mobile, or what we call as a smartphone, was available. And this smartphone enabled internet browsing at the tip of your fingers. And this truly revolutionized every industry in the world, particularly the automobile industry. And why is that and how is that? That's what this story is all about. So moving on. So we said 2007, the smartphone was launched. So today the smartphone in your hand has not less than 20 plus advanced sensors. Temperature sensor, pressure, fingerprint, magnetometer, gyroscope, touchscreen sensor, humidity sensor, accelerometer, GPS units, CMOS imaging sensor for the camera, ambient light sensor, proximity sensor for gesture control. So all of these sensors, which is available to you at about $250, $300, delivering really unique, smooth experience. This is what people got used to post 2007. And by the time we came to 2012, 2013 and beyond, people started to expect smartphone-like functionality, user experience, and HMI, human-machine interface, even in the cockpit of their car. Of course, the advanced technologies always come from the luxury cars to the mid-segment cars, and then they come down to the base economy model cars. So let's take an example here. You can see here Tesla Model 3 and Bolt, and these cars are having multiple sensors. Sensors in the front, sensors in the rear. There are stereo camera models to enable vision. There's a LiDAR for light sensing and point cloud formation or live map, dynamic map creation, so that the car is able to see when in all kinds of weather conditions. And there's a GPS sensor to give the location of the car vis-a-vis a high definition map in order to plot where I am versus where I want to go and then plan the route. So everything that you can do on your smartphone, the car now can do for you seamlessly, just as the smartphone. In fact, the Android operating system, which is there on your phone, there is a automotive grade version of it, which is deployed by Google Android on more than 300 car platforms around the world as we speak. What does that imply? It means, let us say you have agreed to meet your friend on Facebook, and that is on your smartphone. And when you sit when you've decided the time and place of your meeting, you've scheduled a meeting to meet your friend. And when you sit in your car, you don't have to tell the car to navigate. The car will automatically pair with a smartphone, and everything that was on your smartphone apps now displays in the in-vehicle infotainment unit. And in fact, the car will ask you, hey, would you like me to navigate to the meeting with your friend based on what you posted on Facebook? That is how advanced things are today. And you know very well, what I'm sharing with you is not just a science fiction story. It is happening in real life in various flavors, depending on the functionality of the car and what is the premium software that's being installed in the car, in the vehicle. But the next mobile is certainly the automobile. In fact, today, all over the world, because of the pandemic, the global production of cars is having a huge supply constraint. And the supply constraint is not because of components and parts not being available. It's because the semiconductor chips, which is required to create the electronic control units, which is what is the nervous system of the car, is not available. It's not available in sufficient quantity. Therefore, the next mobile is already the automobile. The connected car is today a reality. If you open the newspaper, you will see that all cars are being sold based on the connected car features. So, how does the software-defined car work? So by 2023, these are the various scenarios. This is the art of possible in my worldview. First thing that would become commonplace: contextual software, cognitive cockpit, connected services, personalization. This is the example I explained to you just a while ago. Facebook meeting and the car navigating to that particular meeting intuitively. Internet of cars, vehicle-to-vehicle assisted services, and regulated cybersecurity. Moment you connect anything to the internet, you need to have a cybersecurity layer to prevent hacking and unauthorized access. You need to have regulations to prevent hacking, to make sure that your car is not overtaken by somebody who's remotely hacking it and then creating damage, unlike unlocking or swapping the brakes to accelerator to the brakes. And this was actually demonstrated by ethical hackers in the US in April of 2016 in Detroit on a Jeep vehicle. They remotely hacked the vehicle and they proved that they can hack sitting in Starbucks, they can hack a Jeep which is running on the highway. And Internet of Cars is definitely going to happen, and the foundation for that is already laid. So that is the next scenario. Third scenario, software-defined platforms, all IP architecture and automotive blockchain. What does this mean? Erstwhile platforms. Platforms means the complete design of making a series of products, cars, trucks, buses. The complete design, the master design, if you will, is called as a platform. And from that master platform, one was making different products, right? A low-cost car, a medium-priced car, a super luxury car, so on and so forth. And why was the platform approach required? So that the base components and subsystems, such as the engine, powertrain, brakes, which are applicable to all cars, whether it's a premium car or a base level car, you definitely need to have brakes. You definitely need to have engines. So the base level or the common components and subsystems could be procured together, thereby achieving economies of scale and making sure that product engineering, R&D, quality assurance are all synergistically working in a closed feedback loop. Now that was the erstwhile platform build scenario. To that, mechatronic platform built. Today we need to add a software-defined platform, which basically means I need to have a software company working alongside an embedded engineering team, working alongside a mechanical design and engineering team. So it is synergistic approach. And all IP architecture implies that just like your computer is now connected on a LAN when you go to IGTC or in the office and you have an IP address, 192.168.0.1. Similarly, within the car, there is a network. And this network is similar to the office network, the Ethernet network. And this Ethernet network inside the car will allow gigabit level of data throughput and much more efficient use of cables, power, and data flow. So you will be surprised that the amount of cables runs into few hundred kilos in every car. That's the number of wires required to make a car. So if I'm able to use an IP architecture, then I can use gigabit Ethernet, and then one cable can connect 125 to 150. One type of cable can connect 125 to 150 electronic control units, which is the base nervous system of the car. And automotive blockchain is required in the future because now we are moving into a crypto world. Cryptocurrency, Bitcoin, has gifted the world a new computing architecture, new computing paradigm called as blockchain. And this will allow peer-to-peer computing, decentralized computing with a higher degree of security layers. And there are many smart contract, blockchain gives you what is called as a smart contract, and many smart contract based transactions which can happen intuitively, handshaking with each other without you manually approving. Such as when you pass through, let's say, a toll, national highway toll, it automatically deducts from your FASTag, your wallet gets recharged, and your bank account, amount is reflected, but in a secure way, without you having to authenticate every now and then. So those are some of the advantages of blockchain. Also, when the car is born in the factory, blockchain can allow you to create an identity for the car, such as vehicle information number. And when the car is sold, the vehicle registration number, the vehicle insurance policy, the driver data, all of that can be stored as blocks in a blockchain. And the volumes of data that blockchains can handle are a lot more in magnitude compared to the other computing architectures. So the fourth scenario is increased activity in mergers and acquisition. Investment will be cross-industry, and partnerships will rise out of AI and security-based startups. And you are seeing this already. You can see that Google Waymo has become an independent company. Uber bought a trucking company in order to do autonomous trucking. Daimler bought several startups which are to do with smart mobility in Europe and other parts of the world. And all of the OEMs are investing their surplus cash in setting up incubation centers, open innovation centers, so that they can bring in startups with innovation and new ideas and enable all these new scenarios. And of course, consolidation is also happening, which means the companies which are no longer profitable in the automotive business are going to be acquired and taken over, and consolidation is already happening. As you can see, Renault and Nissan are one. Renault, Nissan, Mitsubishi came together a few years ago. And now you can see alliances being made by Daimler and Bosch to create a new software entity, which they did 2 years ago. You can see that BMW, Volkswagen, and Daimler have come together to acquire, which is what is today known as Here Maps, a mapping company, so on and so forth. Cross-industry acquisitions, going beyond the automotive. And then increase in data sovereignty, car data sharing, owner consent, and AI-based edge platforms. So essentially, like I said, your smartphone, whatever you can see on your smartphone, you will see a mirror reflection in your car. Not only in the familiarity of the apps, but also in the backend operations, as well as in the human-machine interface. You will have voice recognition, face recognition, fingerprint recognition, and all of the sensors, such as the biorhythm sensors, the heart rate monitor, oxygen saturation levels, the fatigue sensor by measuring your eye movements. All of that are already coming into the cars and new vehicle architectures, and this will be commonplace by 23. Mobility as a service, smart living, and people-to-people car sharing and ride sharing. Now, this part is now severely affected because of the pandemic. Nevertheless, we will definitely have mobility as a service, keeping in mind a post-pandemic world where safety and hygiene will be of high importance, and there will be sharing of transportation in order to make sure that we are meeting our carbon footprints as per the Paris Accord, as per Sustainable Development Goals of United Nations. So therefore, sharing and mobility on a sharing platform will become commonplace. And finally, personal assistance. So just as your Siri on Apple, your Google Assistant on Google, and your Cortana on Windows, you will have personal assistants which recognize your voice no matter what language you speak and help you. So why is this required? Because number one, it can prevent theft and unauthorized access of your car. Second is, God forbid, if you are in a situation where you're not conscious or you're semi-conscious while at the wheel, while you're driving, then the car will immediately recognize that you're going down and then ring the National Ambulance Service and try to bring rescue to you or try to bring emergency assistance to you, which is extremely important, especially in a country like India. So these are some of the scenarios of the software-defined car on how the automobile will become the next mobile. So the in-vehicle software architecture, how is all of this going to be possible, right? We have to marry the mechatronic, and then we have to create the embedded electronics. The embedded electronics need to, run on a software platform. Then all of the data will come in. Then I need to convert the data to, information to knowledge, knowledge to insight, insight to wisdom. This has to happen spontaneous, real time. So let's try to understand. First, you have 120, 125 ECUs. Each ECU is essentially similar to your nervous system. So each ECU is a node. So you have an ECU for engine, you have an ECU for body control, you have an ECU for forward warning collision detection, you have an ECU for telecommunications and global positioning system, so on and so forth. So these ECUs run on a special type of software called as firmware. So all of this need to work in tandem with the software of subsystems, and the subsystems here highlighted are advanced driver assistance systems, which means sensors which can give you forward warning collision, blind spot detection, so on and so forth. LiDAR, which is using light as a radar and using light trying to form a point cloud. That means X, Y, and Z axis of the orientation of the car, so the car can see the space in which it is operating, no matter what the weather condition is. And nowadays you have a solid state LiDAR as well, which means no moving parts. Then you have in-vehicle vehicle system, in-vehicle infotainment systems, and domain controller. Domain controller kind of assigns the jobs for every ECUs because you have so many of them. And all of this along with a stereo camera. That means, a left eye and a right eye, just like the human eye system, visual system, you have a stereo camera. So all of this synergistically together is creating a human-like feeling. The idea is to create a robo which can start to resolve the image, not only resolve the image, recognize what is there inside the pixels. Is this a cat? Is this a dog? Is this a man? Is it a woman? And after having recognized dynamically of what images it is resolving, the car now needs to decide, should I brake? Should I turn left? Should I turn right? Or should I accelerate my speed? All of this thinking process, all of this decision-making process need to happen. That's why I need software and artificial intelligence, which is making all of these possible. And finally, you have user experience. So all that you and I care about is that the fact that the car gives us all these functions, and I'm able to move from point A to B safely. And if the car is in distress, it should automatically, trigger a SMS to the vehicle tolling service or the OEM for certain quality problems, so on and so forth. So the connected car communicates. And this is how, broadly speaking, at a 25,000 feet level, this is how things look inside the bonnet. So which means that I will have to have over-the-air updates. So just like your smartphone, sometimes your smartphone will suggest that Android 10.1a patch now available for your Samsung phone. Would you want to accept the update? If you say yes, it will basically download the entire operating system patch. Then it will restart your phone and it will reinstall all the components in your smartphone. And then you will have a new feature, whatever the update promised. Thereby, even though the hardware is the same, you actually have a new experience in your smartphone because of that OTA update. So similarly, we need to do that for the vehicles as well in order for you to have relevant experience. Otherwise, a 2-year-old car will not be relevant in a car which is driven by software. Artificial intelligence and cognitive system updates. So all the operations, right? The algorithms, 3D HD maps, image recognition, this also has to be constantly, the capacity has to be upgraded. It has to have the latest version. Otherwise, let's say if there was a facial recognition glitch in a particular software format where it was not able to recognize under certain light conditions, then you'll have to continue living with that defect for the life of the car, which obviously you will not appreciate. So therefore, as I keep improving in the back end, I need to push those updates into the edge, which is the car, what we call as edge, from the cloud. And then the edge becomes as intelligent as whatever I have on the cloud. And maps, of course, we need to have latest maps in order for maps to be relevant, especially in India, because roads keep changing. You have one day the road is two-way, the other day it is basically one-way road. And then after the monsoons, the roads dissolve, there's no road. So maps need to be updated, and only updated maps are useful maps. Software and security updates, this is obvious, it is required. And then reconfigurable hardware, which basically means that even at the ECU level, I should be able to change my firmware, upgrade my firmware, so on and so forth, in order to enable the promise that I made of giving you the latest experience and seamless experience, no matter the first year of the car, second year of the car, or even third year of the car. And when the car is being sold as a service, you don't have to worry about upgrading the car. The OEM will automatically change your car after 3 years and give you the latest, because you're not going to buy the car. You're probably going to pay a monthly fee to use the car. So those are the business models which are already evolving in various parts, and India also will see this happen. So this is an overall architecture, end-to-end architecture, closed-loop architecture, because we spoke a lot about what happens inside the car, but it's also important to understand what's happening in the cloud. So now I need to have a complete information technology company, IT company, along with being a Bosch, being a Daimler. I need to have in parallel a software company, which is what most OEMs are doing, which you already are aware of. And what are they doing in these software companies? They are building a cloud platform and then integrating the entire supply chain, the entire ecosystem, OEMs, tier 1 suppliers, service providers, content providers, and they have to manage everything that you need to manage on the cloud. Application delivery, over the air, update delivery, infotainment service management, content delivery, software management, cybersecurity, big data. It's a unified platform. And then securely deliver that to the car. And then whatever is delivered to the car, get the feedback real time to make sure that what was delivered is actually talking back to the cloud. So this is called a closed loop architecture. So this is essentially how the big picture looks. So now let's bring everything together from a connected world point of view. So we said that the world today is changing. So the early man, thousands and thousands of years ago, he formulated or she formulated the wheel, right? And ever since the wheel was formed, human beings started to evolve. They understood what's mobility. So cut the latter part of 19th century. You had companies creating cars, and then today what you have is an inverted structure of value chain. You can see the OEMs at top, then below the OEMs you have tier ones, and below the tier ones you have tier twos. So examples: Daimler, Bosch, and tier two is any company you will find which is making components like, let's say, Kalyani Brakes, or any other company which is making subsystem level component manufacturing like SKF ball bearings for automotive. All of these are tier two companies. So this is how the pyramidal structure was, but now it is changing. It is changing into a smart mobility connected ecosystem. So you have the automobile, you have what is called as a neural processing unit, which is the brain processing of entire software within a semiconductor base on the chip, which goes into the electronic control unit. That is the unit of intelligence for the vehicle. Then you have smartphone intelligence coming in, and you have today's generation, that is all of us, who are driven by social media. We want to be connected all the time. There's a lot of the likes, which is creating new user behavior, new consumer behavior, new brand marketing concepts, new digital marketing concepts because of social media. And print is going out and digital marketing is in. And that is also having an impact on how the smart mobility solutions is coming about in the world, and companies have to adapt. And then there's vehicle to anything communication, vehicle to vehicle, vehicle to infrastructure, vehicle to what is called as direct short range communication, so that each vehicle can talk to each other and also talk to other types of vehicles. A car is not only able to talk to a car, it should also speak to an electric bicycle, a two-wheeler, a truck, a bus, in order to work in the real world. And that is why it's called as vehicle to X. And 5G is coming in. Now 5G is a completely new paradigm in telecommunications, because in 5G, what you have is very low latency, very low, less than a microsecond. What does latency mean? The time or the delay between me transmitting a message on the telecommunication network and receiving a response back. Now, this is in microseconds in 5G, and also the communication channels in 5G is omnidirectional. I don't need to have line of sight. In 2G, 3G, 4G, I need to have line of sight. That's why when you go into tunnels and covered areas, you don't get clarity, you don't get connectivity. But in 5G, the entire framework is different. You'll have micro telecommunication infrastructure in every street, and then this will enable indoor communication, semi-outdoor communication. It will also enable IoT, Internet of Things. That means you can have smart home enabled devices, such as your coffee machines, smart refrigerator, smart garages, theft control system, access control systems at home, and similarly in the office. So all of that 5G will enable at a very, very low price, because it has a very high data throughput. In the same amount of bandwidth, I can send a lot more data than I can do today on 4G. And then all this put together is a smart mobility solutions ecosystem. This is what is the world of connected cars, as you can see here. And if this connected car is driven by electricity or fuel cells, hydrogen-based fuel cells, or biodiesel, or any other green solution, then we are heading towards a zero carbon footprint world, which is the world we should all strive to create. So what are the takeaways? Number one, in-vehicle architecture is getting redefined. We said, now we will have a software-defined platform. Second, we will have a closed loop architecture, which means I have to have a cloud, and then the car becomes just like a smartphone. And both are talking to each other real time, 24/7, 365 days in a year. Connected services will become ubiquitous. The OEMs and tier ones have to form new business models in order to give these connected services, offer the connected services. Because so far they are only operating an offline business where they sell to the distributor sells to the dealer, and then so on and so forth. But once you connect, you have to now become a telecom company. You have to work like Airtel or Jio, where people will call in and say, hey, my car connection is not working. Can you check? And then so you need to have all of that, business model innovation. And new business models are coming up, which we just discussed. The entire value chain is getting disrupted to a smart mobility ecosystem-based approach. And the technology and timing, this all is coming in line with very fast development of digitization in the world and across all verticals. And the pandemic has only accelerated this entire process. It is only accelerated. So everybody was sitting on the fence thinking whether I should digitize or not. All those verticals, all those market verticals or industries are now forced to digitize. And therefore, it will have a positive impact on the automotive value chain as well. So those are the takeaways. And in essence, with all of this, what we're doing is we're creating digital twins of future mobility. That means every car, every truck, every bus will have a digital twin on the cloud. So I can actually see the avatar of the car from the OEM side when I'm sitting in my central command and control center. And I know that this is the health of this car, this is the health of the truck, and these are the defects this car is going to have 1 year down the line if this kind of a driver behavior continues or this kind of usage pattern continues. And these digital twins, my friend, is already happening on your smartphones. And that is how Facebook knows your preferences. That is how Google knows your browsing patterns. And the same thing is going to happen in the world of automotive. So that is what I had for you today. And before I sign off, I just want to tell you that I've recently launched a YouTube channel, which I call as Mentor Max channel. And in that channel, I speak on 3 things. One is smart mobility solutions. There are videos, more detailed videos on each of those technologies, which we just touched here as an introduction or as an overview. And then leadership lessons, various things that I've learned, the practical application of management concepts, because management theory comes from practice. It's not the other way around. Books are written after success or failure has happened in real life by managers and leaders. So I've distilled some of the key things which may be of use to you, and then another playlist of wherever I'm speaking in different forums. So this is what I had for you today, and I'm open to questions. Thanks a lot for watching and listening.